note of the following from the video. So the first one is that the wave model of light. So the wave model of light explains why light diffracts, right? As well as why they interfere, right? So from the video, you should have seen constructive and destructive interference, right? So when light passes through a small opening, it bends, right? And that bending is what you call diffraction. So as you can see, the light, this is straight, but the moment it passes through the opening, it actually bends, right? And it continues to move in those opening. That is what you call diffraction. And the diffraction, how come we don't see it all the time? Well, the diffraction depends on the relative size of the wavelength. We all know that visible light, right, is between 400 nanometer to 700 nanometer, which means these are very small, and the only way that we can observe diffraction of light is when those openings are comparable to the size or to the wavelength of the wave, right? So it has to be very small since these are nanometer. Those have those openings have to be comparable to this wavelength in order for diffraction to occur, right? So again, that is important. When opening is wide compared with the wavelength, the spreading effect is small. We don't see it. But as you make the openings narrower or smaller and smaller, comparable to the wavelength of the light, therefore the diffraction of the waves becomes more pronounced. What are the factors that affect diffraction? So again, when wavelength is long compared with the obstruction, the wave diffracts more, right? So if you look at AM radio waves, right, they are very long compared with the size of most objects in their path. So they diffract around buildings and they reach more places than shorter wavelengths. So you don't really need an antenna in order to hear AM radio, right? Because they have long wavelength. And so they can go through buildings, right, or other obstructions. While when you look at radio waves and TV waves, right, compared to AM waves, they have shorter wavelengths, right? So I remember when I was growing up, I really need to make sure our antenna is working because those TV waves hard to see, right? Those channels because there's no cable TV, there's no satellite TV when I was growing up. So antenna is a must in order for FM and TV transmission to occur, especially if you live in areas where there are a lot of obstructions, right? So you have trees, hills, and all that. It is also applied in electron microscope, right? In an electron microscope, a beam of electrons has a wavelength can be very, very small, right? Shorter than the wavelengths of visible light. So, which means in that case, it is easier for light to diffract. That's why you have your electron microscope, right? So I want you to take note of that, right? That electron here, it behaves like light. It has the ability to diffract, which we are going to look at in the next segment. Is there an experiment that proves this? Yes, it's what you call the Young's interference experiment, otherwise known as the double slit experiment, right? So Young was the one who established, right, that light behaves like a wave, right? Because of the pattern. And in the video, you've seen that you have bright and dark fringes, right? Or the pattern that you see. Sometimes we call it fringes or points within the screen. So if you have light here, right, you have your slit, As long as it's very small, then you can have your bright and dark pattern. And that is a product of what we call constructive and destructive interference, right? So again, it's light, dark, light, dark, light, dark. Again, the light is a product of constructive interference. That light has the ability to be added, and the dark is what you call destructive interference. So I think is that is it for light. And those are the things that I want you to take notes. So you can always go back to this and read it to yourself. But I'm just highlighting the things that are very important to understand when we say light has a wave like nature. I hope that is clear.